Hello everybody, this is Rudra Pradhan here. Welcome to Engineering Econometrics. Today we will continue with count data and discrete modeling. In the last couple of lectures, we have highlighted this concept, that to understanding the count data and discrete data, and accordingly we have also identified various models relating to count data and discrete data. So, we can directly go to various structure of count data modeling. So, basically the structure is like this. So, we have the concept called as count data modeling, and the starting is actually to understand the data. In the last couple of lectures, we are strictly discussing various models relating to data structure, starting with time series models, then cross sectional models, then penal data models, and then count data models. So, in the count data models, we specifically highlighted some of the structure, that is with respect to data types. So, that means here the type of data is like this, that we have continuous structure, we have discrete structure, that is what here. So, that means technically, so the data division will be continuous type and then discrete type, and it can be negative while in the continuous structure, and if it is really negative, then we will follow the normality distribution, and if not, then log normal and gamma distribution. On the other side, we have discrete structure, and that to number of outcomes. If it is with respect to 2, that is what we call as binomial, and if it is many, it is called as Poisson's or negative binomial or multinomial. So, that is what the a typical structure about the kind of count data modeling. But what is happening here, we are not going in details about this modeling structures, we are strictly discussing these aspects only, that to playing the game between Poisson distributions and negative binomial distribution. Of course, we have highlighted these two models in the last lecture, and again we are bringing this particular structure to connect certain examples where we can use actually Poisson distribution and then negative binomial distribution. Accordingly, we have two different models that we need to highlight under the count data modeling, that is Poisson regression modeling and the binomial regression modeling. And the choice of these two models, which we have already highlighted, this basic structure starts with calculating mean and variance. If mean variance are equal, then we can actually use Poisson distribution or Poisson regression modeling. If mean variance are not equal, then we may go for negative binomial regression modeling. That is how the beginning of this entry, or that to with respect to count data modeling. So, what I will like to highlight here, I will bring some of the examples where we can actually connect with this a kind of Poisson regression modeling and the kind of negative binomial regression modeling. Before that, I like to bring one particular concept, since we are discussing about the fitting models that to relating to count data. So, we have couple of issues here. One issue which we have highlighted is called as overdispersion, and then this is called as robustness. In many instances, these assumptions underlying the likelihood function are wrong. Some data points are too unlikely, so that data points are outliers. So, that means technically it means we have already discussed this concept, that is the outlier in the heteroscedasticity problem. It is a very dangerous kind of component, which also having actually problem in this count data modeling. Outliers can be either be left out in the analysis or likelihood rustified to reduce their influence. That means, we have lots of instances, means we have lots of possibilities where we can reduce the impact by normalizing the data or some kind of restructuring of the models or something like that. But ultimately what is actually requirement, there should not be outlier in the final setup. So, that the model may not be actually creates any kind of problem so far as prediction is concerned or the kind of forecasting is concerned. So, the requirement is that minimizing the median residuals, leaving out the largest residuals and downweighting large residuals. This is how the kind of structure. So, again contradictory data is that all probability statements are based on the assumption of the model and likelihood function, and these may be actually wrong. Often when we have two data sources, they disagree. The problem is that one data source is not actually measuring what we think it should be. What is exactly the solution? That includes some probability that each index does not tell us anything, and run separate assessments for each index in turn. So, that means, we have a kind of different structure of handling the data and then the kind of modeling. So, let us have a look here. Contradictory data. The one part of this particular structure follow a kind of simple patterns, and the other one is actually having some kind of different. Okay. So, that means actually one way you can say that one increasing, the others not. So, that means there is a kind of huge obstacles in the setting of the data and the kind of modeling. So, let us bring some kind of cases relating to Poisson distributions or Poisson regression modeling and then the binomial regression modeling. So, here actually we have some sample occurrence and the observed frequency. So, that means technically, so how we actually apply here, these are all observed structure corresponding to the possible values. So, that means what is happening here, the key research question is that falling at random or under a guidance systems, if random independent events should be distributed especially as a Poisson distribution, then you have to follow the particular structure by calculating mean of this particular series and then variance of this particular series. So, after calculating the mean, so we will find here 0.93 having the particular data availability. Now, if you go to next slides where you can actually report the kind of variance, sometimes what is happening, it may not be closely tied, but if it is slightly converse to each other, the equality may not come because of round up errors, but somehow if it is actually equal and converse to equality by mean and variance, then we can easily apply this kind of regression modeling. So, similarly, there is another kind of situation here, number of soldiers killed annually by earthquakes. So, here we have actually data structures that is actually with respect to frequency distribution and that to group data of death occurrence, and the frequency corresponding to each frequency is available here like these ones. So, that means technically again, so this is what the frequencies and the corresponding observations, and then we will again calculate mean and variance and corresponding to this total observations, and then we come to conclusion that since mean and variance are equal, then you can easily again apply the kind of say regression modeling that too with respect to Poisson distribution. Now, likewise another kind of examples here, similarly see the death occurrence frequency. So, then again the structure is actually to connect with Poisson distributions, and then check whether the mean and variance are coming each other. If they are same, then again you can go for Poisson regression modeling. If not, then you have to go back to the binomial negative binomial regression modeling. So, basically the Poisson regression modeling is like this. So, it is exclusively exponential type, which we have already discussed in some extent in the case of regression modeling with different functional form, that to the game between linear regression modeling and non-linear regression modeling. So, here these kind of models what we are discussing related to Poisson regression modeling and binomial regression modeling, where actually we are actually strictly focusing on nonlinear regression modeling. So, the only difference we are bringing here is with respect to data structure only, because here the data structure is that this similar kind of model, but the type of data, the information contents relating to the variable must be a count data, that to integer types, and then avoiding the kind of negativity. That means, we need actually simple non-negativity integers only. If the data structure is like that, then by default we will go for Poisson regression modeling and the kind of negative binomial regression modeling, subject to checkpoint of the mean and variance. If they equal, then we will move to Poisson modeling. If not, then we will go for negative binomial modeling. So, it is a similar kind of flow here. So, this is how the kind of structures which we like to apply in the case of count data modeling. So, now coming to this particular structure again, we have a kind of a structure what we call as overdispersions. That is the case where mean and variance are not actually same. That means that there is a question of over identify case. So, again, so we have to the same problems, maybe whatever we have discussed earlier. Of course, we have cited problem where the case is actually mean exactly equal to variance, because our intention is to connect with the Poisson regression modeling, and here again our intention is to connect with negative binomial regression modeling. So, as a result, we have to bring one such problems where we like to justify or bring the scenario that the mean and variance are not actually equal. So, if it is actually equal, then we will go for Poisson distribution or Poisson regression modeling. If they are mismatched, then we will go for some kind of other structure what we call is a negative binomial regression modeling. So, the classic example is here, where if you club these two samples, that is the main groups and women groups. So, where we find mean and variance are unequal, that is the case of overdispersion. And if you go by clustering, that main clusters and women clusters separately, what is happening here? So, mean and variance, and again mean and variance all are same. So, that means, if you go for that means technically in this kind of problem. So, we have three different kind of models. If you have a clubbing and that two group samples, so then we can use actually negative binomial regression modeling. And if you go by sample specific men separately and women separately corresponding to the data and the kind of inference between mean of this particular series and variance of this particular series, then you can apply Poisson regression modeling. That is what the interesting about the count data modeling. The same data set, if you pool, then we will have actually structure where we can apply negative binomial regression modeling. And again, if you go by clustering, so you can apply actually Poisson regression modeling. But ultimately, this kind of modeling, the clue is actually somehow same. Of course, we have already discussed the case that where if you increase actually a sample points indefinitely, that means technically n stands to infinite, then by default they will equal each other. That means, there is no such big difference between Poisson distribution and negative binomial distribution. Of course, the density function of Poisson distribution and negative binomial distributions are different, but ultimately the outcome so far as regression modeling is concerned followed by density function may not actually so much difference, which we have already highlighted in the case of dummy modeling, that too in the context of nonlinear regression modeling with the help of logit and probability. The same structure we will follow here with respect to Poisson regression modeling and binomial regression modeling. Now, to continue again, so this is the case where we can apply both the models simultaneously, and this is how the structure. And in the case of negative binomial distribution, which is the case for overdispersion, the same structures we have to start with log of this density function subject to all the independent variables, which we have already highlighted here. That's the case here. Okay, and same way, so the typical variance factor is here, and here the link is that the variance and mean are not same. So variance is greater than mean. So that's how the over identify structure, and by default we will use actually negative binomial regression modeling. Okay, so that's the case where we apply negative binomial distributions. Now we will highlight some kind of linkage between binomial and Poisson distributions, and that too negative binomial regression modeling with Poisson regression modeling. So somehow actually mean and variance again. So means you see it's a game, it's a mean and variance. So if you increase the sample size, then by default they converge each other. There is a high chance, and as a result then both can be actually tie. And ultimately our objective is not to check whether to use actually Poisson regression modeling or negative binomial regression modeling. Of course, that is the requirement subject to data structure. Ultimately we if you increase the data size or sample size, so we have twin advantage, because higher the data or higher the sample size, model accuracy will be much higher, and then again we may be in a position where data will be normally distributed, and then finally this kind of an environment both the distribution can close each other. As a result, we can instead of going for two different kind of setups, it's better to apply a single model and then analyze the situation as per the particular engineering requirement. That's how the deal, and this is kind of examples where we have actually calculated the kind of mean and variance, and then justifying the kind of requirement. Again, so what I have already mentioned, so if you increase the sample size n stands to infinite, then there is a high chance that the distribution will be close to each other, and the kind of over dispersion factors can be actually removed, and then finally the kind of Poisson distributions and the kind of negative binomial distribution can be actually close to each other. That's what actually requirement. But what is happening in practice, both Poisson distribution, negative binomial distribution, it's a kind of rare occurrence, and less than 10% of instances per interval, or 100% thousands like trial cases will find such kind of situation. That's why these models, and that to count data model is a very exceptional kind of situation where we have to apply subject to the kind of chances and the kind of occurrence. Otherwise it is not possible to apply this kind of modeling to study the impact of independent variable to dependent variable. So this is how the kind of distributions structure, and here what is happening here. So if you find graphically the deviations, so this is actually Poisson case where mean and variance are equal, and this is negative binomial distributions where variance greater than 2 means, and then corresponding to Poisson distribution and negative binomial distribution, then we have a concept called as Gaussian distribution where variance unrelated to means. That's what the case. And then we have binomial where actually a mean and variance proportionately converge towards similar kind of structure. So, that means we are bringing here actually 4 different kind of distribution, starting with the Poisson distribution, negative binomial distribution, then Gaussian distributions, and then binomial distributions. Of course, Gaussian distribution is a very interesting distributions, but ultimately whatever distribution we can actually think about it, you can think of course it exclusively depends upon the data structure and the kind of requirements, that the features of the particular data. So, that means since our discussion is actually with respect to Poisson regression modeling and negative binomial regression modeling. So, ultimately whatever sample structure is there, provided the data will be specified as a count data, then in the first instance we have 2 different choice, the Poisson structure and then negative binomial structure, and that too the choice of a particular model exclusively again depends upon the mean and variance. So, if mean variance are actually same, then we strictly means we directly move into the structure of the Poisson regression modeling. And if there is a overdispersion case where mean variance are not equal, that means variance greater than to mean. So, we can go to the negative binomial regression modeling. But in addition to Poisson regression modeling and negative binomial modeling or negative binomial distribution, we have other type of distribution where we may find in a real life situation corresponding to some of the engineering problems. Again, if that will follow, then obviously one way actually to streamline the case and go as per the particular requirement is actually to increase the sample size and the kind of data transformation. So, that means what is actually in our hand always, that you can normalize the data and then you can increase the sample point, so that a proper analysis or the kind of proper inference can be drawn, subject to availability of data and the kind of the particular identify problems and the kind of engineering requirement. So, if your data size is very small and the information contents are not count data type, then we may not be in this particular environment, and we will not think about too much about this particular issue about mean variance equality or the kind of over dispersion case. So, that means technically we have lots of instances through which actually we can highlight, but technically what is happening here, some of the cases where the modeling structure will be subject to the kind of these survival structures where actually we like to apply. And let us bring the situation where we use actually this Poisson distribution and negative binomial distribution. What I like to bring a situation here specifically with respect to count data, and the structure is that it is a specialized case where data is actually positive integer types, but what is happening in real life situation, some of the instances where the kind of for instance the accidents, then the incidents and the death case. So, these are the cited examples where this kind of modeling can be used. For examples, there is a concept called as survival structures. We have actually a component called as survival analysis, which we will discuss in the next lecture. So, where actually the particular data will be by default will be count data type, and we like to check how they behave each other, and then what kind of modeling you can apply, and then how to go about the model choice and the kind of estimation procedures and the kind of outcome, the robustness checks and the kind of reliability check, and then finally come with a kind of situation where you can actually predict the survival rate subject to availability of data and the kind of problem requirements. So, that means technically till now whatever we have discussed, so it is basically related to count data and then we have discussed two specialized kind of problems, and that to Poisson regression modeling and then negative binomial regression modeling. And then we have highlighted some of the instances and the kind of requirements and the kind of checkpoints through which you can make a choice between Poisson regression modeling and negative binomial regression modeling. And then again we have highlighted a situation where both can actually converge to each other, and then we can bring a situations where we can either use actually Poisson regression modeling or negative binomial regression modeling by increasing the sample size and bringing the accuracy to the systems and the kind of model requirements. With this we will stop here, and in the next lectures we will connect a particular problems called as survival analysis corresponding to this count data modeling and the kind of Poisson regression modeling and negative binomial regression modeling. With this we will stop here. Thank you very much. Have a nice day.